Hello, I'm Holly Lynn Lee, and I'm here again with my good friends and colleagues, Susan, Webster, and Chris. And in this unit, we're really diving into a resource that is, here in the United States at least, housed by the American Statistical Association called Census at Schools. But there are also international sites that are housed in various locations that collect data from students, and teachers have access to all of this data that have been collected over the years. So have any of you used the Census at Schools resource, and how have you used it in your classes? Webster? Yeah, Webster?
Well, I haven't actually used it in my classes,
Okay.
but I'm very familiar with it as a resource.
Okay.
It's an interesting data resource in my opinion. So
Uh-huh.
at least here in the States, I've done a few webinars with the American Statistical Association on using the Census at Schools, and I have some ideas about that. But one of the things that you understand very quickly when you start working with Census at Schools is data can be overwhelming.
Mm-hmm. Yeah.
Right? I mean, you can get a lot of information of some questionable value sometimes. So as I've looked at this data, particularly the quantitative variables that are in the data, it really reinforces that idea of cleaning the data.
Yes.
That's something that's very real
Right.
that you have to do almost always in practice.
Mm-hmm.
So if you just try to do a histogram of some of these variables, you'll see very quickly that there's some junk, some values that don't even make sense.
Yes.
That are completely obscuring your ability
Yes.
to look at the rest of the data. And you have to start the filtering process, and you have to sort of slowly filter this down until you can get something that's reasonable.
So
to
for
consider.
example, I know one of the variables is the number of text messages you have sent yesterday, something like that. And I have seen that data set where there is an answer of 10,000. You know,
Right.
a student put in 10,000. That's in a day. I don't even think that's physically possible.
I don't know. There's some very
Very good.
I'm
Very
not
good
sure.
tips if you type.
So that's probably somebody with a sense of humor.
right.
You
Or
know,
mistyped.
Or mistyped. Yes.
And they're in no way typical of everyone else, right? So,
Right.
As an outlier, you don't want to let that person have an impact on what you're saying about the rest of the data.
Right.
And that's where that filtering process becomes very, very important.
Mm-hmm. Yeah, I agree.
I've used Census at the schools with a course that I teach at the University of Georgia that
Mhm.
is for high school teachers. And I have usually a mixture of pre-service teachers as well as in-service teachers in this class. And one of the main reasons I expose them to this data set is for what Webster just indicated, is that it's not a clean data set.
Yeah.
And that it is an accessible data set to where I think they could maybe develop some tasks or
Mhm.
use it in their classrooms because it's relevant questions
Right.
for their students. But at the same time, the beauty of using that data set is that it helps students see that in the real world, this is the way most data sets look.
Yeah.
They're not clean,
Right.
and that they're messy, and you need to learn how to clean them up, how to filter things.
Yeah.
When is it permissible to delete an observation of 10,000 text messages? When is it not permissible to delete an observation?
Right.
So I think that's one of the nice things about this data set, is it gives a real world exposure
Yeah.
to how data sets look.
Yeah, yeah. So I think we teach a very similar course.
Mhm.
And so one of the ways that I use it in my course for teachers is we first look at the survey
Mhm.
that all the students take, and so they get to understand kind of the questions that are asked, where the data comes from. So
Mhm.
we talk about all the different measurement issues. We're able to think about the kind of variables that you're going to get from this question. What type of output are we going to get? What kind of variation
Mhm.
might you expect, might you anticipate? So there's some anticipation there. And then I get them engaged in. So if we download a sample of this data set and we have access to all these different variables and you look through these different survey questions, what questions might you pose? And we go back to this variable. So if we're going to do a statistical investigation where we use some subset of this data, what questions are you interested in? And can we pose a good statistical question that this data set would allow us to answer? And so that's one way that I get my students engaged, and they work in groups, they pose questions, and then each group is working actually to answer a different question. So they're not all working on the same question. And then they have to actually do their investigation and report their results and share that with the class and kind of convince their classmates that they have done a thorough enough job of the investigation and supporting their argument. So that's one way that I've used it with teachers.
One other way, oftentimes in statistics, we always show comparing groups, for example, that we always find those examples where there is a significant difference, right? But if you work with the Census at Schools data, you'll see in the real world, significant differences don't happen all that often. And I think that's actually valuable. So a student shouldn't expect, my p-value should be low. It's not. There's something wrong. So you could easily use that data to show many examples of where things aren't statistically significant, and maybe find one or two where they are.
Throughout this MOOC, we have all mentioned technology. We're all very avid users of technology, and we really see it as a central role in what we do in statistics. So when we're using technology to analyze our data and to help us interpret our results, what does it bring to the table? What kind of affordances and constraints does technology allow for us when we're in this phase of the statistical investigation?
I'll just offer a couple observations,
Yeah.
because I always go back. I have been around quite a while, and many years ago, the first piece of software I ever used for statistics was something called Cricket Graph. Did any of you ever know that? I loved Cricket Graph. It was the simplest graphing software I'd ever seen, and I think I was writing curriculum then. And then later, I taught a course where people at Bull Brannick and Newman were developing a piece of software, and we tried that one too. But the thing that struck me when I used it, as simplistic as it was, and you were learning how to make bar graphs, but I was learning about the structure of graphs in a way I'd never learned about when I did it by hand. What's the scale? How are you going to do 2D, 3D? I mean, all these different decisions you make, and then I started thinking about, the impact on learning. And at that time, I was also getting in software for mathematics too. And my feeling was that the software built a level of depth and comprehension of understanding in ways that you could not do without using technology. And so now I helped, I was on the advisory committee for the development of Tinker Plots. I think that's a brilliant piece of software in the sense that kids have data objects they mess around with, and they move, and they put it into different shapes. They express their representations any way they want. They have to make sense of it. And I've always felt it's probably one of the most brilliant pieces of software, particularly for upper elementary and middle grades, in terms of kids making sense of what data is all about before you ever even go into the fathoms or other kinds of analysis.
They can create very non-standard and informal
And they do.
visualizations.
And they do. They do these
Absolutely.
amazing interpretations and things like that as well. And what they're learning is a whole different way to think about data analysis and statistics at a much deeper level, what I call the visceral gut level, that they will never lose. And that then translates into the more abstract representations you might use with other kinds of software at some point. But they need the intuitive building too. And we've never been able to do that before. Technology is our only real way to do that.
Yeah.
So.
Yeah.
Well, I'm gonna date my age now.
Okay.
So I'm finishing.
We've all got the gray hair showing
Yeah,
here, Chris.
we do.
You're among friends.
So I'm in my 35th year of teaching at the collegiate level, and I often say that when I think back about my first few years of teaching the intro stat course, I am so embarrassed at the curriculum that I delivered to my students. It was definitely more the computational, procedural type curriculum. That was the way I was taught. But it was in the 1980s that I became exposed to statistical software, and my first really big experience with software was with Minitab when I was at the University of Florida on faculty there. And this is when we still had line commands, which I still find myself when I use Minitab, like, can I go back and use my line commands instead of pull down menus? But I think the beauty that I found with Minitab, and this was really a turning point in how I taught my courses, as well as using Friedman Presenting Purpose. I have to say, that is a fantastic book. I tell my teachers that you should have that book on your bookshelf, A Friedman Presenting Purpose. But was the ability to simulate that I found with Minitab. And so this whole idea of teaching statistical topics such as sampling distributions, or trying to develop the idea of what we mean by a margin of error, or with confidence intervals or p-values, even though it was a bit clunky with Minitab, it still changed the way I taught. And I think to where we are now, and it's just truly amazing. I mean, the ability of our software for just visual displays, as you mentioned, the art part of
Yeah.
statistics, but also the ability to simulate, for students to just see what's going on. It's not just something magical. They can actually experience it. And I think from a K through 12 level, technology has allowed us to truly introduce statistics at the K through 12 level, because we're able to teach sophisticated concepts like sampling distributions, like p-values, like margins of error at the high school level.
Right, in very intuitive ways.
In very intuitive ways, and as the Common Core is promoting, it's all through simulation,
Yeah.
through randomization tests. It's not the traditional probability distribution-based inference that we're still teaching in our college intro courses. So technology basically has changed the way we teach. It's allowed us to teach courses to where we can help students become statistically literate now. We're not teaching them procedures anymore.
Yeah, yeah.
So as you might guess, I have very strong opinions about technology.
I'm sure.
And I, have to
And I
say,
hope you do.
I'm similar to Chris. I think back when I was teaching 20 years ago, and what I teach today, it's very different.
It's
The
very
approach is
different.
very different. And I suspect many people are in that boat. But
Mhm.
you know, I think about the class I teach now, and in statistics in general, it's impossible to teach it without technology.
Oh, yeah.
Yeah.
I mean, it's
Yeah.
crazy. I mean, and
I just take it as a given.
yeah,
It's
you,
a given.
You don't use a calculator, okay? Nobody does that. You know, that's one of my pet peeves. You know, statistics is not something you should think of pulling out a calculator, a handheld calculator, just to try to solve problems with. So, you know, my ideas about technology have developed over the years. I would say that, you know, I see really two ways that technology makes a big difference. You know, so I use StatCrunch in my courses, of course, and you know, to me, it's a learning tool in that I can put data in front of the students very quickly, okay, and have them looking at the data, thinking about the data. They can generate results quickly, you know, whether they be formula types of results or graphs. You know, it allows us to look past the formulas and those types of things and focus more on interpreting what's there.
Right.
Okay, so that's one way that software in general can help
Yeah.
out. And then the other way, you know, I think technology's had a big impact on the way that we teach certain concepts, and that we can develop these sort of interactive demonstrations that are focused, like on sampling distributions. So in StatCrunch we have an entire applets menu, right? That's the education side of the package, where you can pull one of those out and use that to teach statistical concepts.
Yeah.
And that's something that we could never, that did not exist
No.
prior to the 1990s. You know,
No.
when I first started teaching, it wasn't available.
You didn't have that.
And now I think they're incorporated almost everywhere.
Right, right.
So, you know, that's another way. So just that working with data and being able to focus on interpretation rather than formulas and things of that nature. And then those specific things, there's certain concepts that I can't imagine teaching without technology. And so addressing that is important as well.
Yeah, yeah. And one of the things that I love whenever I use different software packages, no matter what it is the ability to actually, when I'm creating, I've got my data set. It might be represented in a table. It might be represented in data cards if I'm using something like Tinkerplots or Fathom. And when I create a graphical representation, I might create several graphical representations, and all of those are internally linked together. And
Right.
so if I select a data point in one particular graphical representation, I see where that case is represented in a different representation, and I see where it is in the table, and so I can go find out more about that case. That might lead to more interesting questions. So the ability to kind of link among representations, I have found to be extremely powerful in the way that I teach my students and my teachers to explore their data, and it helps to kind of get them. They might think that they're still focusing on the question that they originally posed, but then new questions start popping up because they're able to actually think about it in different ways. And then I also really think that, with thinking about the conceptual understanding, that the ability to be able to change a data point and see how that affects different measures, you know, computing that, if I was doing it by hand, what's the point? You know, I mean, it would just take forever. But if I can change a data point and I can see how that affect the mean or the median, or I remove an outlier and I see how things shift, that's a real powerful learning tool, I think, for our students. So I think we've brought up some nice points.
I think it's also important as for teachers, because one of the things I hear a lot, especially for K through 12 teachers, but it's true at the college level as well, is sometimes they say, well, I don't have access to these software packages. They cost money, don't have the resources to get those. But there are so many wonderful free resources
Right.
available on the internet, and Webster mentioned applets. I have found that using applets is one of the things I'm going more and more toward
Right.
within my own classrooms, because then you don't have to rely on software.
Yeah.
Students don't have to pay for it, that you don't have to have them in the computer lab.
Right. Right.
So trying to utilize resources that they can easily just access from their own laptops or their computers.
Right.
It's much easier to do that now.
Yeah, yeah, and throughout this MOOC, we've actually introduced you to a lot. One of our core things is that we wanted to give you access to lots of different free tools that you can easily integrate into your classroom.